Okay, adding and subtracting rational expressions. So just like with regular old fractions, multiplying and dividing is easy, and adding and subtracting is a bit harder, right? The whole lowest common denominator in that, but let's run through the steps. So factor all the denominators completely. Don't worry about the numerators yet. So if you see a plus or minus, then you know you want to factor denominators, okay, and not numerators. If you're multiplying, dividing, simplifying, then it's factor all numerators and denominators. Once the denominators are factored, state the restrictions from the factored form. Determine what the lowest common denominator is, the lowest common denominator. And then, back to 4.1, express the rational expressions as equivalent rational expressions with that lowest common denominator. At that point, you're going to add or subtract the numerators, but the denominators stay the same. Remember, just as with regular fractions. We'll take a look down here. Collect like terms in the numerator. Express your answer as one rational expression, and it could be that that expression needs to be simplified. Okay, so let's take a look. We'll go through some examples. So just as with regular fractions, we do not add the denominators, right? We need a common denominator. That's going to be tens. This will be multiplied by 2 over 2 to give 6 over 10. Multiplied by 5 over 5 to give 5 over 10. We get 11 over 10. Okay, again, restrictions still. So all of these guys, because you've got a monomial denominator, it's just that the variable cannot be 0. Okay, there's nothing to factor when they're monomials, right? So we would factor. Okay, that's not doable. We state the restrictions. Now the LCD. So we need the lowest common denominator for the numbers, which is 10, so a number that they both go into. And then it's going to be the higher power of x. So 10x squared is my LCD. And here's what we do. So we take the 3 over 5x squared, and we're going to multiply it. So remember, we're multiplying by something that's equal to 1, but we want to get 10x squared, so that's just going to be a 2. Whatever we put in the denominator, we also put in the numerator. Plus, I'm going to move this. So let's say LCD 10x squared. Okay, 1 over 2x. So to get a 10, I put a 5. To get an x squared, I put an x. Whatever's down here goes up here. Equals. Okay, so we have 6 over 10x squared plus 5x over 10x squared. So it just becomes, so now we add the numerators. We don't change the denominators though, right? So 5x plus 6 over 10x squared. Okay, here, so x cannot equal 0. And our LCD, so the biggest number that 4 and 8 go into is 8. Biggest power of x, so 8x squared. So we start with the 1 over 4x. What do I multiply 4x by to get 8x squared? So 2x. Whatever goes in the denominator goes in the numerator. So remember, we're doing equivalent rational expressions, so we multiply basically by 1. So 3 over 8x squared. Now we don't have to do anything with that, right? If you really want to put something there, you just put 1 over 1. Let's throw an equal sign in front. So this is equal to 2x over 8x squared minus 3 over 8x squared. So 2x minus 3 over 8x squared, right? Still, x can't be 0. Over here, so we have x cannot equal 0. LCD. Now, you can simplify this before you do anything, okay? I'm not going to. Let's just see what happens if we don't simplify beforehand. Okay, we're still going to get the same answer. So we'll go with the LCD is 60x squared. Okay, so separate that out. So 4 over 12x squared So to get 60x squared, I'm going to put a 5 down here. I'm going to need 5 up here. Plus 3 over 5x. And to get a 60x squared on the bottom, I'm going to put a 12x, top and bottom. Don't forget the equal sign. So we get 20 over 60x squared plus 36x over 60x squared, which is 20 plus 36x. Actually, you know what? Let's put the variable first. So let's go with 36x plus 20 over 60x squared. And now you can see, well, okay, hang on. I mean, they're all even, right? So 2 goes into everything, but 4 goes into everything as well, right? Because 4 goes into 36 9 times. 4 goes into 20 5 times. And 4 goes into that 15 times. Now, as long as they all share a common factor, we can just divide that out. And then we look again, 9, 5, and 15, and we go, no, no common factor. So an alternative could have been, we could reduce this. That's a 1, that's a 3. So let's just kick up here. So we're looking at 1. Wow, stuff keeps happening. Let's go big. We're looking at 1 over 3x squared plus 3 over 5x. So still, x can't be 0. But you notice our LCD now would just be 15x squared. Which means we'll get to this form, you know, kind of right away. 1 over 3x squared. So I want to get a 15x squared. We've got to put a 5 top and bottom. And 3 over 5x. We've got to put a 3x top and bottom. So up here we get 5. So, you know, I'm just going to kind of do this. So 5 plus, and over here 9x, and our common denominator is 15x squared. Right? And these two guys are the same. You know, order different, but it's fine. Okay, when you have no denominator, put down a 1. So our else, well, first our non-permissible value, and again, because it's a monomial, it's just x cannot equal 0. Our LCD will be 8x. The 9 over 8x doesn't need anything. Write that as 3 over 1, and then put it as 8x. Oh, you stopped. My pen ran out of ink. Why? Not working. Alright. I had to close it down. Okay, so we want an 8x in the denominator. So we're going to put 8x over 8x here. So we know the denominator is going to be 8x, right? So what do we got here? We got 9 plus 24x. Okay, good enough. So you're going to look and see if there's any reducing, and there isn't. So we'll just go with p cannot be 0. My LCD. So what's the small? So the way that I do an LCD is I just say, does 6 go into 10? No. And I take multiples of the bigger number, right? 20? No. 30? Yes. So the LCD is 30p squared. Now we have a binomial here, but let's, so 2p plus 5 over 6p squared. So to get 30p squared, we're just going to go 5 over 5. Minus 3 over 10p. So to get 30, we'll put a 3. To get the p squared, we'll put a p. Whatever goes in the denominator goes in the numerator. Distributive law. So 10p plus 25 minus 9p. See that there. over, so instead of writing them separately with their denominators, I know that both denominators are going to be 30p squared. So 10p minus 9p will be p plus 25 over 30p squared. Okay. This guy, so x cannot be 0. And the LCD, well, 6 goes into 24, and then we need an x, so 24x. So we don't have to do anything to this. X minus 4 over 24x plus 5/6. Okay, to get 24, we put a 4. To get 24x, put an x. Whatever goes in the denominator goes in the numerator. So we have, so we know our denominator is 24x. We have an x minus 4 plus 20x. So 21x minus 4 over 24x. Simplify, this time binomial denominators. Okay, so restrictions. X cannot equal -2, -4. The LCD, x plus 2, x plus 4. So you'll find with binomials, you need the whole, binomial thing, right? Like you need this whole term. So this gets a little bit tougher, but let's do this. So we've got 3 over x plus 2. Now, my LCD is x plus 2 times x plus 4, so I need an x plus 4 here. And remember, equivalent rational expressions. The 5 is over x plus 4. So I need an x plus 2, x plus 4, so down here we need an x plus 2, and up here an x plus 2. Okay, 3x plus 12 plus, okay, watch this, 5x plus 10 over, well, we've already got the common denominator, right? So instead of repeating this and writing like 3x plus 12 plus, and then writing 5x plus 10, and each one over this, we can just combine. So 8x plus 22 over x plus 2, x plus 4. Again, with the proviso here, and there's nothing. What I would look at is, does this factor? Because it actually does. You could take a 2 out of this, but you'll get 4x plus 11. So when would I factor this numerator? When one of the factors will be one of these guys, and then I can cancel. Okay, so we'll look for that later on. Okay, so y does not equal -1/3 or -1. So 4 over 3y plus 1. Wait, we need the LCD. So for our LCD, look at see what we've got here, right? We've got a 2. So I like to look for numbers. We've got a y plus 1. And we've got a 3y plus 1. So our LCD is actually 3 terms, okay? So this is going to need a 2 and a y plus 1. And if that's what goes in the numerator, it goes in both the numerator and the denominator. Plus 1 over 2 bracket y plus 1. Okay, throw that in brackets. And that's going to need, so it's got the 2, it's got the y plus 1. It just needs a 3y plus 1. And whatever's in the denominator goes in the numerator. There we go. Should be an equal sign there, a nice equal sign. Alright, here's going to do the same thing again, right? So we know our common denominator is going to be a 2, a y plus 1, and a 3y plus 1. So what do we got up top here? See, 4 times 2 is 8. It's going to be 8 times y plus 1. Well, you know what? Let's not get too fancy. And here, we've just got 3y plus 1. So this is 8y plus 8 plus 3y plus 1 over, and we've got our common denominator, 3y plus 1. Okay, so we get 11y plus 9 over, okay, and then the common denominator, 3y plus 1. Okay, so, it's a bunch to do, and if you've done 20-1 and you're comfortable with these guys and you have a different way you want to do it, then by all means, go ahead. If you're not sure, you can just ask me, hey, is this a valid way to do this? Does this work? Look at this, because we can make this a lot simpler, right? So we got a 3, a 6, and an 18. And what does that mean? Well, 3 goes into all of them. So you divide 6 by 3, 3y by 3, and is that minus? Yes, minus. So, or you could factor a 3 out of that, right? Which you would have to do, and then you could divide the 3 into this. So y cannot equal negative 6, and the LCD now is y plus 6. So I got an LCD of y plus 6. I've got 2y minus y minus 1. Watch this. Okay, this minus sign distributes through. Equals, so 2y is y minus 1 over y plus 6. And by recognizing that this term could be simplified, so you're allowed to simplify a single term. By recognizing you can simplify this, we save a lot of work. Okay, let's do a few more. So, the power of the fingers. Step 1, oh wait, if I can make stuff bigger. Okay, so this is 3, and this will be a 4 at 2x plus 1 minus x, and x is the common, and we get 2x plus 1. Okay, step 1, factor the denominators, right? We don't factor numerators when we're adding and subtracting. And the reason is they're going to get combined, they're going to get messed with, put together, they're going to be simplified. So if we factor them, we would just end up having to put them right back to what they were. So x is not negative 1/2, negative 1/2, and 0. Okay, so we don't repeat. Don't go negative 1/2, negative 1/2, 0. And the LCD is, well, I need a 4. Need an x. Need a 2x plus 1. So it's really like 4x times 2x plus 1. So 3 over 4 times 2x plus 1. So this is missing an x. Minus. You know what we could do? Wait, let's back up. See this? So we need this to get that 0, right? But we can take that out. So now our LCD just becomes 4 times 2. See that we can simplify? Because there's an x top and bottom, it's a common factor. So we can just take that out, right? At some point it's got to come out. Okay, like now I don't have an eraser. I'm going to wear through this screen. I pushed too hard. Alright, so, wow, just keeps getting bigger and bigger. Equals 3 over 4 times 2x plus 1 minus, so now this is 1 over 2x plus 1. So it's going to need a 4. So this doesn't need anything to get the common denominator. So it's going to be 3 minus 4 over 4 times 2x plus 1, or negative. So you could put a negative 1 up top. You could just put a negative in front. Say it's the negative of this. Okay, or, hang on, or just put the negative up top. Just go -1. 3 minus 4 is -1. Right, and then that restriction holds. Ooh, I like this one. Make it bigger. I actually have room to write. And I'll shrink it and the printing will get small, but that's fine. Okay, equal. Do it again. Okay, so you got 3, x plus 3, 2x. You forget to factor this, you're in for a whole lot of pain and a wrong answer. So you'll just end up spending a whole bunch of time on the test trying to do this, and you're just going to end up getting it wrong anyways, because it'll be way too complicated to ever simplify. Okay, factor. So look for the difference of squares. This is two terms with a minus sign. Okay, fix that. Why didn't anybody say anything? Two terms with a minus sign, so difference, and then check, right? So 3x minus 9, okay, and then that's a difference of squares. So x cannot equal, I'm going to say plus or minus 3, right? Because that comes from this, so minus 3 plus 3 plus 3, so just plus or minus 3. The LCD, I always like to write it down. So we need a 3, we need an x plus 3, we need an x minus 3. So this 3x minus 3 needs an x plus 3. And this x plus 3, x minus 3 needs a 3. Okay, what do we want to do with this? Here, we can do this. So in the denominator is our LCD. 3, x plus 3, x minus 3. Here, see here we get 4x plus 12. Plus, and this is only one term, right? So plus 6x. So 10x plus 12 over 3, x plus 3, x minus 3. Okay, done. We'll leave that there. You can pause if you want. Equals. Okay, sum of squares do not factor. Difference of squares, kind of a backwards one. So 2 plus x, 2 minus x over 2 minus x. So x can't be -2, can't be +2. So you can write that as plus or minus 2. And the LCD is 2 plus x, 2 minus x. 2 plus x, 2 minus x. So that's got everything we need. Plus x, 2 minus x over 2 minus x. Let's not lose that minus sign. That bracket there. So minus, maybe put this in brackets. This is going to need, right, it's going to need a 2 plus x. And another 2 plus x here. Okay, let's see what we got. So in the bottom, 2 plus x, 2 minus x. That's a minus there. X squared plus 4 minus, okay, let's do this. So it's going to be minus 2x and then minus x squared. Okay, so this is a minus x being distributed through here. Minus x times 2 is minus 2x. Minus x times x is minus x squared. So these guys, okay, it's not factors I'm canceling, right? It's just x squared minus x squared. It's just 0. So we've got 4 minus 2x over 2 plus x, 2 minus x. Now wait, I could take a 2 out of there, right? 2. And if I do, I'm going to get 2 minus x. And hootie kazootie, look at this. Now this and this are the same. And so our final is 2 over 2 plus x. Okay, so a little complex, right? But just remember, you can't factor a sum of squares. This is a difference of squares, has to be factored. There's nothing to factor here. Once we've got this, we do the non-permissible value, the restriction really. Figure out the LCD, right? This has everything it needs. This just needs the 2 plus x, so we're going to multiply that. Here's our common denominator. There's nothing happening here. It's just x squared plus 4 minus x times 2 minus 2x minus x times x minus x squared. I crossed them off, but you notice I didn't put ones there. I didn't put 1 because it's not a factor that I'm saying this is the same as it is. Divides out. This is x squared minus x squared. It's just 0. Then, oop, look at that. Those are both even. If you factor it 2 out. So you always want to look, right? I mean, if I can factor something out, but it won't cancel down here, then don't bother. But if I factor a 2 out, I get a 2 minus x. And it's like, well, I've got one of those down here. So I factor out the 2, and away we go. So that is... Ruh-roh. What happened to this answer? Okay, hang on, fit width. Okay, I'm just going to pause for a sec. I have to rewrite this because we need it for the, Okay, we're ready. Jimmy, so this type of word problem, like you may see something like it. Usually they're going to give us a table, so we'll develop the table together, but oftentimes in the question they'll actually give you that table. But here, we'll draw the table out as we go through. So Jimmy swam 500 meters upstream to his cousin's cabin. So that means he's swimming against the current, right? The current's flowing downstream. He then swam 500 meters back to his own cabin. The speed of the river was 100 meters per minute. Okay, so that's the current. Assuming that Jimmy swam at a constant speed, okay, let's make a little table. So this is distance, this is speed, this is time. This is upstream, downstream. So he swam 500 meters upstream, so that's your distance, 500 meters. His speed, well, let's call his speed x. If he's going upstream, though, and the current is 100, he'll be going x minus 100, right? Because he has to work against that. So his speed, the x is his speed in still water, x. Jimmy in still water. Right, so if there were no current. Downstream, 500. When you're swimming downstream, you get the assist of the current, so it's x plus 100. Time is distance over speed. So it would be 500 over x minus 10, and 500 over x plus 10. So this is a chart that has all of the information in it. Now, we're not actually solving this because I don't think we have enough information to solve, but it says assuming Jimmy swam at a constant speed, that's x. Okay. Jimmy's constant speed is x. Write a single rational expression. So the total time will be the time upstream, right? Time upstream, 500 over x minus, let's go to what looks like tens, over x minus 100, plus the time, 500, downstream. Okay, now it says write a single rational expression, so we need to combine these, right? So first off, we can start by saying, it's going to go down here, x is not equal to 100 or negative 100. Okay, so that's going to make sense, right? I mean, if the current speed was 100, he wouldn't go anywhere, right? If he's trying to swim against 100-meter speed, but the speed would be like one of those infinity pools. He could just keep swimming, but he's not actually going to go anywhere. And it can't be negative 100, right? I mean, first of all, that just doesn't make any sense. So these guys here, the non-permissible values or the restrictions, usually aren't going to make sense in a problem like this. But we need an LCD, right? So we're not solving this. So the LCD is just going to be one of these, and it's not a 10, and one of these. So let's just go time is 500 over x minus 10, and our LCD 100. 100. Okay, so we multiply that plus 500 over x minus 100, and that's a plus 100. Okay, so that's going to be x minus 100, x minus 100, right? So our LCD is one of each of these guys, right? So this one already has the minus, it needs the plus. This has the plus, it needs the minus. I get lazy. I don't want to write out two things, this expression and then this expression. So let's just multiply. We got 500x plus 500 and 2 zeros plus, because it's total time, so there's another 500x minus 500 and 2 zeros. So this and this go away, and we're left with 1000x over x minus 100, x plus 100. So if they told us the total time, we would set it equal to this and we would solve, right? But solving is another lesson. Okay, so this is just getting a single rational expression, and we did. Jill invested $100 in shares of $1,000, and been dropping zeros all night. Clean my glasses. Jill invested $1,000 in shares of a stock on Monday, and another $1,000 in shares of the same stock on Tuesday. On Tuesday, the price was 25 cents lower than on Monday. So she'll get more shares on Tuesday, right? Because it costs less money, so she'll be able to buy more shares. Write a single rational expression that represents the difference in the number of shares that she bought on the 2 days. So she would have bought more shares on Tuesday, right? It's cheaper, so she buys more shares. Okay, so let's do this. We will let x be the price of the stock. So notice we're not solving this stock on Monday. So if the stock price was $1 and she bought $1,000 worth, it would be 1,000 divided by 1, or 1,000 shares. If the price was $2, it would be 1,000 divided by 2, or 500 shares. So what we're going to do is we're going to do Tuesday minus Monday, right? Because she bought more. Tuesday shares, let's say number of shares, Monday number of shares. Okay, and that's a single rational expression, so that's the difference in the number of shares. Let's call that like diff. Okay, so on Tuesday, she put $1,000 and she bought x minus 0.25, right? Because on Tuesday it was cheaper. Minus the number of shares she bought on Monday, which is just 1,000 over x. So this is it, but we want this as a single. So first off, x cannot be 0 or 0.25. That's just kind of intuitive in the sense of this. You can't buy stuff that costs nothing. And then you can't have a negative price, or if the price here was less than 0.25, this would end up being negative, and that just doesn't happen. So our LCD is x times x minus 0.25. Okay, we're not solving this. That's like tomorrow. X minus 0.25 times, that needs x's minus 1,000 over x, and x minus 0.25 minus 0.25. Now let's do that same little trick, right? Here's my LCD. This will be 1,000x. Okay, minus, now watch this because we have to expand this. So it's going to be minus 1,000x. Minus, and you see the minus and the minus, so plus 250. So that works out to 250, right? 1,000x minus 1,000x is just nothing. All right, and there is our expression for the difference in the number of shares that she bought on the 2 days. Okay, and again, we're not solving this stuff, right? That's tomorrow, the next lesson, whatever that is. That's for then. Okay, we're done. Do some homework.